Have you seen this website before? It's a popular website. Yes? All right. So the idea here, right, and if you want like a quick refresher on like what we explained in Mod 1, was that in your Mod 2 project, you would basically load this page. All right. Have you seen this website? It's a pretty popular one. Right? How do I eat for cheats? Right? I don't know. Wow. There's actually some weird things that come up. Either way, the point is, this is what your Mod 2 project looked like. You would display something. It'd be a particular page. And then if I needed any additional information, I had to click this next, request the data, make a new GET request, and then the server will respond with the next batch of data. And it would just be this full page refresh every single time I wanted something. Whereas something like maybe Twitter, Airbnb, if I keep scrolling, if you take a look at this like scroll bar on the side here, boop, 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 boop. Let me grab it. Oh, embarrassing. So here, look what happens when I get to the bottom. I'm like, oh, this is the end of it over here. Oh, wait. But wait, there's more. It's like Oxy. You know what I'm saying? Yeah, we do. Okay, wow, damn. Oh, tough crowd. I remember you guys now. But yeah, the idea is that I can keep going, and essentially I don't have to do that full page refresh. I don't need to necessarily click on something so that I can get more data and basically add it to the web page, because that's really what's happening in English.
But then what's the difference if you were to like click on a button on this page and you like it would take you somewhere?
Yes. So what I want to demonstrate to you is why this is beneficial and why this user experience is so good. So let's take a look. Right now, back in the day, when I was growing up, I just barely missed the pager era, but like my dad had like a beeper, which is pretty cool. But the thing is, mobile data didn't have this like unlimited plan. You have to like pay for texts. Remember this era? Okay, like 4 of us. Okay, very good. All right, forgot this class is kind of young. But the idea right now is that mobile data it can be expensive, but we're also limited, right? You have like unlimited data up to like 2 gigs, and then it slows you down. So you want to use as little data as possible, because if you use little data, you're downloading less and the user experience is better because the page loads faster. So if you open up the DevTools, have you like learned how to use this yet? If you hit Command-Option-J or Command-Option-I, it'll open different tabs, but these are the DevTools, the developer tools for this browser. So I can, in fact, do something like this. I can open up the Network tab, and what you'll see is if I hit refresh, we take a look, this right here will demonstrate everything that it downloads. And if we take a look, boop, 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 let's get rid of this console. You'll take a look at everything that it downloads on the right-hand side, and that is like the image. So I have to go download like this Coffee Dad image, right? I have to download like this tweet icon. I have to download the nav bar HTML. I have to download this follow button. I have to download this image right here. I have to download all of these like, hey, I might actually like these real human beings on the side here. I have to download all of them, and you'll see them all actually here downloaded. If you look quickly at your HTML, you'll see things inside the head tag, right? Like here's some script tags, some CSS tags that you'll download. And the idea is that when I make the request, it sends back HTML. In your Rails app, you had that application.html file that was like the overlord of all your files, right? Then everything was just yielded to that block. The truth is, every time it sends that whole thing. It sends the doc type, it sends this HTML, it sends the head, it sends everything. So in that response, it sends this whole HTML. And now my browser has to go download every single thing. It has to download every CSS sheet, every JavaScript file, and anything else you put in here, any additional images or anything that you need to download and load. And it loads all here in the Network tab. You could see all of them. And if the download was good, you get this status 200. And so if you scroll through, oh, womp womp. Looks like old Google Pixel didn't load here. Embarrassing. But the idea is that like you can click on any of these. Like this is some ad. You could see it like sales.png from like ABS. But like look at all the stuff that I have to download. Every time I refresh the page, it has to download all of them again. And you'll see that you can even scroll open this little thing right here, and it should show you the size. 2 kilobytes, 2 kilobytes, 6 kilobytes, 100 kilobytes. That adds up. That means that if I'm really doing my math here, this could be like all of this, maybe like 1/3 of a megabyte. But then that stuff adds up really fast, because how many times do you visit a website? If I click and I go sign up, I have to go download all of it again. If I click this person, I have to download all of it again. So 1/3 of a meg, 1/3 of a meg, 1/3 of a meg. I hit 3 sites just clicking, that's 1 meg. And then like 1,000, quote unquote, is 1 gig. And all of a sudden, just browsing the internet for maybe an hour, hour and a half, I can get a lot of data transferred. And so here's what actually happens though. Like, let's take a look at the bottom here. If I scroll all the way down, look, it only makes this 1 extra request. And it's kind of small, it's 2.9 kilobytes for the more tweets. Versus if I go on Google and I click this, you'll actually see on this network tab, if I click this next, I have to download everything again. I click next, I have to download everything again. But if I'm on Twitter, do I need to download the nav bar again? Should I have to download how many followers this person has? Should I have to download these side images and these people? Or do I really just want to make a just quick tiny network request, get the next 20 tweets, and put it on the page? What would be a better user experience? It's just in your mind. Right, the continuous flow, and you're using less data so that the website loads faster, it's a little bit more responsive, and it taxes you less. And it taxes me less as a developer because now I don't have to send all of that data across the server as well. So like everybody sort of wins in that regard. Does that answer your question?
What's the significance of waterfall?
We do, so I'm just gonna like touch on that for 2 seconds. The idea is certain things have to download in a certain order, like a waterfall. Like you can't get to the bottom of the waterfall unless it's falling from the top. You know what I mean? So like if I'm downloading, like it has to hit all of them first in a particular order. So if we look at it, I have to download everything here. It's gonna tell me how long everything took. And then in the timeline, it takes more time to download stuff in the future. So it almost looks like this waterfall that's happening. Cool. Great. All right, so let's actually go forward. So the beauty of JavaScript is that at some point, JavaScript in the beginning, naturally, was just not very popular, right? It was built in 10 days. It was super buggy. So people were like, oh my God, why am I going to use this like language? It doesn't really like super do anything crazy. But like I was trying to tell you in terms of like this user experience, back in the day, do you guys remember AOL? I'm using all these old references.
Yes.
Do you remember You've Got Mail? Remember this?
Yes.
It only happened when you first logged in. Your mailbox didn't actually refresh. You had to close the mailbox, open the inbox again, refresh it, and then it would go check to see if you had more mail. That was like a terrible user experience. The idea now is I can leave Gmail open, and if something comes up, it's just always kind of always listening. If something comes up in my inbox, and then when something new comes in, it will shoot me an alert like, oh, hey, by the way, you got another message. Or like it would pop it up on the screen sort of instantaneously on its own. And so because of things like that, and the beautiful thing like, you ever seen this website? You ever use this? Boop, 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 boop. This website?
Yes.
Google Maps. I'm logged in, so I'm gonna scroll away from where I live. You know what I mean? But let's check this out. Like if we look at the network request, every time I'm scrolling, back in the day with MapQuest, I couldn't do something like this. I had to click up and they would move up and download images again. I had to click right, it would move right and download all these images again. Now I have this beautiful seamless experience where if we look at the network tab, none of this sort of reloads. None of this reloads, but what it would do is on the scroll, it's gonna take just this portion. It's gonna go make the request for that data and then put it on the screen. So if you take a look over here on the right, as I scroll, it makes all of those requests just for that part of the data. And so that's why JavaScript is so popular now, because it interacts with the browser and it gives you behavior and functionality without needing to necessarily do that full page refresh. So let's review the request response cycle and how that's sort of helpful. You're on a browser, you're on your Rails app, right? You click this form submit, it sends it back to the backend, the controller. The controller does two things, right? It interacts with the model. Do I need anything? If I go to animals, like a get to /animals, right? The server hits it. Do I have the route? And then it asks the model, great, I need animal.all. It sends it back to the controller, right? So that's like the database. And then it sends you the response with that HTML. You rendered index. It sends back index.html with animal.all, all the animal objects. And then it throws it on the screen for you. But here's the thing. What if you wanted to show just the first 20 animals and you had 2,000 animals in your database? Well, you would make a request to get to animals. It would hit the server. So your controller would be like, you know what? 2,000 is too many. That's crazy. Let me just send the first 20 back. So it interacts with the model and it does like a, hey, give me the first 20. And then it sends back the HTML to the page. Now, on the browser, what you could do is you could scroll to the bottom, and when you're at the bottom, JavaScript will now make the silent requests in the background. Like, hey, listen, I know there's 20 on the page, but let me get the next 20. So 21 through 40, right, is the data comes from the model, and then it sends that response. But the problem is the browser already has something there. But then you can use JavaScript again to just bloop, sneak it right onto the page. And that's basically what's happening for that better user experience. So that's the request response cycle with not only a regular standard request response, but also what is known as like this asynchronous request, right? I'm gonna do something in the background and then I'm gonna add it to the page. Cool? So far so good? So just a quick history of JavaScript. Very quick history. There's like a ton of things that happen here. Do you remember, does anyone look familiar? No? Yo, Chet, like half the class nodded. I mean, shook their head. So, back in ye olden days, when you would surf the web, I don't know why people would say that, but you would have something, right? Best viewed in Netscape Navigator. Do you, like, some of you will remember this. This is, oh my lord. Okay, I don't have internet right now, that's fine. The point is, there was a browser called Netscape Navigator, which is now Mozilla Firefox. There used to be something called Internet Explorer. You're not that young, right? That's still, it's a thing? Okay. All right, now it's Microsoft Edge, yeah. We have Chrome. And so here's the thing. Each one of these browsers is what runs your JavaScript. The browser will run your JavaScript. So that means if Netscape is running your JavaScript and Mozilla is running your JavaScript, and then Firefox or like Chrome, remember Opera? There was like a BlackBerry browser for a little bit. Each one would run your JavaScript differently because there was no standardization, which is wild. So imagine you wrote in Ruby, all right? You wrote .each on an array, and it would go through every single one. And you're like, okay, that's the normal behavior. But in like a different browser, what if .each skipped every other one? You'd be like, oh my God, this is crazy to me. This inconsistency of how JavaScript was executed caused a lot of problems. So if I wanted very fun, cool behavior on my website, I'd be like, look, listen, run that bad boy in Chrome, because if you open it in Internet Explorer, it's just not gonna work. Because Internet Explorer ran JavaScript differently. It would see the exact same code and do something slightly different with it. So it wasn't a perfect user experience. And so that's what became known as the browser wars. And that is like Netscape competed with Internet Explorer to say, use my browser, it's better. No, use my browser, it's better. And, you know, just didn't really work. So the authority came together, this European computer, oh man, I gotta fix that. That's not a good user experience. The European Computer Manufacturer Association, known as ECMA, ECMA, eventually came together to be like, all right, we have to standardize this. Across all the browsers, this is exactly how the .each is gonna work. This is exactly how certain selectors are gonna work. And so eventually, they came across what is known as like ES 2015, but we call it ES6. You can also call it Harmony JavaScript. There were a lot of iterations to this, right? There were like ES3, ES4, which stagnated for a while, then fell off, then ES5. I learned ES5 because I learned JavaScript back in 2015, and this came out toward the end of 2015. So if you don't like adding semicolons, right, that's ES6. You're welcome. Not that I had anything to do with it, but yeah, I had to force semicolons in my own code. It's crazy. So anyways, that's what the browser wars are, right? And so now we're in this like beautiful idea of like what JavaScript is. So I want to talk a little bit how JavaScript gets loaded. So if you look at your HTML, right, this is your basic HTML. Let me blow that up a little bit. Is that more better? Do you guys want the light on or off? This is fine? Okay. So the idea is that like you have your regular HTML, right? You have no CSS here, like no lame, no styling. This is how I run it. I literally put in this script tag that will go and download the source index.js. So somewhere in my folder, there's an index.js file, and it's right here. Bloop. This is going to be the JavaScript that runs in my code because it was downloaded by the browser because I sent it over with a reference to it in my HTML. So far, so good? So that being said, if I simply were to open index.html, I am at my page. I could see the browser there. And if I open it, I could see the 3 console logs that come up. Console log is essentially puts. Right? It's just going to print to the console, and you'll see what came out. You can color coordinate it because sometimes you'll need a lot of different console logs to like test different things. So you can color code them for like organization. All right. So any questions so far on how your browser runs JavaScript? How do I run my JavaScript file? I can't just do Ruby space the file name. I should put it inside an HTML file, open up the browser, and let that bad boy run.
So it's downloading when you do like source index.js, it downloads that file?
Yes, the browser will download the index.js file and then run and execute it.
Is that like what you were doing before when you were like scrolling and it was like downloading it in the...
It's downloading like images and data that JavaScript told it to do. And we're going to get to how we can get JavaScript to do that. But the idea is this, right? And if anything happens on the page, right? Like look at this intro.js. If I double click it, what happens? Maybe like intro gets highlighted, but that's kind of the computer, right? If there was a button here and I clicked it, right? What do you think happens? Let's take an example, right? Let's do this. Button. Great. I said, hit me, baby, one more time. No? Okay, all right. Okay. Click me, all right? Just, for those that are a little, oh my goodness, there it is. Wow, I gotta fix that zoom. What happens when I click this button? Nothing, right? This button doesn't do anything. So if I go bloop, 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 like nothing is really happening. I can get JavaScript to interact with this button, and we're gonna learn more about that tomorrow. And that's kind of like the whole idea. Cool. So, let's go back to this, all right? What I want to do is like a quick review of all the weekend labs so we're all on the same page, and that way we can talk a little bit about like how JavaScript's like a little bit different, the nuances, and then this afternoon I'm going to dive into some more specifics about how Ruby and JavaScript are different, but for now I just want to talk about the fundamentals so that we have a shared understanding. So here are the 7 data types in JavaScript. What was it like? What data types did you know of like in Ruby? You knew like hashes, some arrays, strings, right? Integer. So here, JavaScript really only has like 7 data types. We're not going to talk about symbols too much, but there's something called undefined, right? What is undefined in JavaScript for those that did the labs?
It's essentially if you have like a variable or something that you declare, but you don't set it equal to anything, it doesn't have a definition.
Yes, that is exactly correct. If I have a variable that exists, but it doesn't have any value, that variable is undefined. So, for example, let's take a look. In my browser, I can actually run valid JavaScript. So I can do var, I can do swaglord. All right. Here is the declaration of the variable. I'm using this keyword var, and I'm saying the name of the variable is called swaglord. I can then assign it a value and say eat for cheats, right? So that is 2 things at once. It's a declaration and an assignment. If I simply say, hey, there's going to be a variable called swaglord, and I let it fly, I could see, hey, what is the value of swaglord? It should be undefined. There's no value associated with it, which makes sense. So far, so good? Now, what about null? What is null?
It's like the absence of that.
Yes, right? There is like, so undefined is when there's no assigned value, and null is when there's actually no value at all. So for example, like I declared var swaglord, but I never declared var chet. So what is the value of chet? Oh my God, chet actually is not defined at all. So there's undefined and there's not defined, and they're completely different. So far, so good. So the idea is that Null is like the direct equivalent of nil in Ruby, right? There's like actually no value assigned, but I'm assigning it no value. So for example, I can say chet, varchet, I'm going to declare it, and then I'm going to assign it a value of null. So swaglord is undefined, and chet is null. Why would I sort of need this? Why would this be important?
Debugging.
Yes. How so?
You can figure out for one if like it ever hit your variable pretty easily, because maybe you just bypassed your variable.
Oh my god, exactly, right? The idea is that if something comes back null, I know it should be empty because I assigned it. If something comes back undefined, I can be like, ooh, something went wrong with my app because I tried to assign it to be an array, but it came back undefined. So that means that JavaScript didn't know what it was, so that somewhere in my code there's a bug. But if it comes back null, I know, hey, continue running the program, it's all good, because I know it should be null because I forced it to be. I assigned it. So that helps me determine whether or not there's a bug or that that's the intended behavior.
When would you want to assign something to null?
When you want something to start out as empty and then get a value later. There will be 101 Dalmatian examples later. And so just bear with me. Cool? So far good. Good on null, undefined, not defined. Noise. All right, Boolean. I'm not going to go into this. Boolean is just true false, right? There's no change from JavaScript to Ruby. Easy peasy. All right. There's something called number. Back in Ruby 2.3 and like 2.4, I think, there used to be something called fixed num, and then now there's just integer. So number in JavaScript encompasses everything. So you have like integers in Ruby, and then you have floats, right, which are different data types, technically, different classes. In JavaScript, they're all the same, right? You have like exponents, anything that's like a decimal point, they're all just numbers. All right, and then string, and then object. So let's go into them. All right, I'll go into that later. So in terms of a string, right, the way you did string interpolation in JavaScript and Ruby is just slightly different. So in Ruby, right, you use the double quotes for string interpolation, then use this pound sign with the bracket and just go Ruby, and then that's how you do it, right? So far, so good. In JavaScript, in order to do string interpolation, you can either do like concatenation, which is chet, and then you can do the variable, right, chet plus swaglord plus yeet, right, and then you'll get chet undefined yeet. So you'll have to do it this way, but the modern way to do it is with this like string interpolation. So you hit these backticks, which are the keys to top left to the left of the number 1 on like a US keyboard, and you'll see it just becomes a string. So if I do something like this, and let me just define swaglord. You guys have like you guys like bid anything? Swaglord is chet? Oh my god, I knew it. So if I do now with this, I can put your boy, right, who is actually, and then the string interpolation is the $sign. So you'll hear me often say like money, friggin' money. And then I could put chet in here. Oh, sorry, swaglord. Obviously. And then that will like do the string interpolation for me. So it's the backticks and the $sign. That's like the slight difference. Cool? You guys learned this in the labs? Feel Gucci about it? Gucci Mane? Okay. But yeah, numbers are interesting. So here's the thing. We can parse int to change a string into a number. So if I have like a number like 1, 2, 3, that's just a number. If I had a string 1, 2, 3, it does not equal, there's a 3 equal signs, 1, 2, 3. But if I put the double equal, this should be true. So does anyone know the difference between the 2 and the 3 equal sign? Evan, sure.
Double equals will do type conversion, so it will attempt to make them the same type as possible, and then it will check for equality. Triple equals only will return true if they're of the same type.
Right, so there's a strict equality operator. So you almost always, 99% of the time, use the triple equal in JavaScript. Cool? So here's the thing, right? If I had the string 1, 2, 3, I can convert that into a number using something called parse int. And then I pass it a value, and it'll convert it. The thing is, what if I had ABC? What do you think comes up instead of 1, 2, 3? This NaN. Does anyone know what NaN stands for? Not a number. Have you guys ridden the subway and then you've seen like the subway stop? It'll be like, oh, hey, the next C train is 17 minutes away. You're like, mother. Anyways, sometimes there's an error and it'll say, hey, the next C train is NaN away. It's because they're using JavaScript. It means that like whatever they try to do interpolation-wise messed up. So it's just kind of cool and interesting.
My
So
favorite is minus 2,147,000, whatever it is. Like
sometimes it happens. So the idea is that if it tries to convert something that's not actually a number, it'll return, hey, this is not a number, which makes sense. But what if you do this? What is 1, 2, 3 ABC? It's just 1, 2, 3. It will try to coerce them until it hits something and it's like, oh snap, this is no longer it, and it will just stop. And so this is one of those weird things that fails silently. So if you're writing code and you're not checking it, you're going to assume that it's going to try to convert everything, but it just stops in the middle of it.
What about ABC 1 to 2?
What do you think happens? Yeah, because it hits the first thing and goes, oh, this is not a number, it just stops. Cool? All right, so Boolean. Here's the one thing about Booleans that you want to talk about. In Ruby, the only two things in Ruby that are false are what? False and nil, right? In JavaScript, there's just quite a few more. False is false, money. 0 is false, empty string is false. So you have null, which is fine. And then undefined and not a number are also falsy. Cool? I won't ask you to memorize a lot, but this you will have to just memorize if you're looking for more comprehension.
Did you say that null is not false?
These are all the falsy values in JavaScript. Yeah, that's okay. Yeah, everything here is falsy. If it's not one of these 6, it is considered truthy. Cool? Yeah.
Question.
Send it.
Why is 0 considered false?
Why is 0 considered false? I believe it's just 0 is considered like no value, so that would be falsy. That's just the philosophy of the language. I mean, I'm not Brendan Eich. I didn't make that determination, but I would assume that that's sort of the mindset behind it. Cool? So, that being said, everything before that we talked about here, right, are called primitives. So your strings, your numbers, your booleans, undefined nulls, all that, they're all primitives. So if we're to look at all the data types here, these are all primitives, 1 through 6. The next thing, the last thing, number 7, object, is known as a non-primitive. You don't actually have to memorize that, except the fact that objects do not behave the same way as everything else in Ruby. So let's take a look at that. Primitives, like numbers or strings, they're passed by value. An object are passed by reference. Who feels like they have a strong grasp of this concept? Great. So just a quick example, right? I can have var3 is equal to the number 3. Right? So if I do 3 plus plus, right, what's the value of 3 now? Should be 4. Right? Let's do another example, right? I can have var5 equal to 5. And I can have a var of 5 equals to 5. Right? So 5 and 5 have the same value. So if I do 5 and I look at 5 again, it's actually 6. But what's the value of 5? It's still 5, right? Which makes sense. Those values are passed by value. Let's take a look at an object. So I can have var, right? I can have object. And that's going to equal to what is known as an object in JavaScript. This is exactly the same. I want to say that. For your understanding, these are exactly the same as Ruby hashes. So they're just key value pairs. If you know anything about Java or Python, they're called dictionaries. It's just key value pairs. So you can have an object with the key of Charles and a value of entertainment cheese. Right? So you have Charles Entertainment Cheese. Very good. So cool. I can do var object2 and assign it the same reference as object1. So what is object 2 right now? It's an object with the key of Charles with the value of entertainment cheese. If I look at object and I add another key, right, like swag lord, equals like better give me my money, right? Cool. So let's take a look at obj. It's Charles and swag lord. What is object 2? It also has 2 keys. And this is because objects are passed by reference. So what that means, right, for like the same understanding amongst everybody, is that when I created the object, I said there's an object. And in memory, let's just say memory location 1, it's going to hold a key value pair. When I assigned the same quote unquote value from object 2 to object 1, I'm telling it, hey, object 2, you're going to reference the same place in memory, which is going to be the key value pair. So if object 1 changes and it messes with the place in memory, now it holds 2 keys. Object 2, which points to the same place in memory, it will reference the same place in memory. So that means that object 2 will mutate along with object 1 because it's the same place in memory. It's the same reference to the same object. So far, so good? It's just the same object, right? Cool? All right. All right, so those are what are known as non-primitives, just objects. We haven't talked about arrays at all. Does anyone know what an array is?
It's a special kind of object.
That's right. Array, the way JavaScript does it, is just a type of object. And you can prove that because if you want to check the type or the class of something in JavaScript, you can simply put type of. So if I put type of something like 7, it'll tell me it's a number. Does anyone know what not a number is? What the type of not a number is? It's a number. So not a number is a number. JavaScript is weird, but that's okay. It's just a type of number, all right? So if I were to put something like type of, and then I were to put in an object, oops, that's wrong. It gives me an object. The same as if I were to put in array. It's just a type of object. Cool? So if an array is a type of object, are arrays passed by value or are they passed by reference? By reference, right? So if I do the same thing to an array, right, they're placed in the same point in memory. Cool? All right. You'll never hear me say this except this one time, and that is a plain old JavaScript object is called a POJO. If you ever see this, that's what that is. I think it's very smart and very cool, and therefore I don't use it ever. But yeah, that's what that is. So if you see like, oh, this is a POJO, you're gonna be like, wow, you're weird. But yes, I understand what you're saying. Cool? Just a plain old JavaScript object, just key value pairs with the curly boys. Yeah? All right, cool. All right, so let's talk about like how JavaScript does anything. In Ruby, you built methods. Yeah? In JavaScript, you're gonna build functions. And we're gonna talk later on about what the difference between a function and a method is. But for right now, you could think of them as essentially the same for now. So this is the syntax for it, right? You just write the keyword function followed by the name of the function, and then regardless of whether or not it takes arguments, you gotta put the bananas. You need the bananas. And then to open the function, you have to put the curly boys. Cool? So let's just write a function, right? So function keyword followed by the name of the function, right? Like I love lamp. So notice how JavaScript does it. The first thing is always lowercase, and then there's no underscores. Anytime you have a new word, so to speak, it's just capitalized. This is known as camel casing. And then Ruby, this is the snake case version, right? You have underscore love, underscore lamp. So JavaScript will be like this. Cool? And then, regardless of whether or not you need arguments again, you drop the bananas, then you open, and you close, and then you do something here, like console log, right? Enter man. Cool? So now I have this function called I love lamp. Now, what is I love lamp if I just straight write it right here? That's right. It's a reference to the function. So I love lamp is a reference to the function because you could see it right here. Now functions are special types of objects that allow them to be what is known as invoked. You can actually execute the code that's inside here just like you would in Ruby, and that is the difference between this and trying to execute it is just the bananas. You just got to run it with the bananas and it'll run the code. So this right here is the definition and this right here is the invocation. Are there any questions as to the difference? You will run into this a lot because in Ruby, you will write this a lot and then nothing will happen. And that's okay. You will also probably forget the return keyword. You guys okay with the return keyword? Okay, it's gonna be okay. It just takes a long time. All right.
Do we need a return keyword for every mod?
Almost always and forever, you will need to return something from your function, but you should not put it on every line. Return will break out of your function and stop. So, for example, if I were to have a function like, oh look, functions are objects, return nice. If I do any code here, it will never run because return will just be like, oh, the function's done and stop. Cool?
Do you know of any like extension or add-on that will like help you remember return?
That helps you remember return.
Like it'll be like hey, you-
Time will punish you.
Okay, but-
Practice.
But it's like you put a variable on the last line, so clearly you're not like trying to.
Yes. What I don't want you to use, but you can choose to use it, are what are known as linters. VS Code comes out of the box with it, and it will like underscore and highlight for you things that you've sort of like wrote incorrectly where your code will not compile. I don't personally like having students use them because you become very reliant on them. You don't see the errors, then you fear the errors, and then they don't become your friend. Like me and errors hang out every weekend. But if you don't really hang out or talk to them or see them often, when your code breaks, oftentimes you won't know why. So that's why I advise against it, but it is there available. Cool. Linter is spelled this way. Ironically, I'm going to tell you what it looks like. Linter. Yeah. So like ESLint is pretty good. I think that actually will let you know that this function returns nothing. It'll like give you a warning. Okay. All right. So we go down like the definition, the difference between the definition and reference and invocation. You'll even see like the highlighting change. So it'll let you know. All right. Okay, we talked about type checking. And the last thing I want to kind of like get you into, because we have like a part 2 to the lecture today, is back when you were mod 2, they were like, hey, make it work. Just throw it on the screen. If it's in the web browser and it's working, go ahead and pass go, collect $200, and you should be good to go. Here, we're back into actually learning the fundamentals of the language again. So just like in mod 1, where like we needed you to actually write the full method, have everything work, it's because it was TDD. In mod 2, we use something called Capybara, which is like adorable but frustrating. All right, is BDD, behavior-driven development. It expected a very particular ID or the input written in an exact way so that Capybara can sort of click through your app and test to see if it's working. We didn't want to force you to make sure it fit under Capybara standards, so we just said, hey, if it works, you're good, move on. But here I want you to get back into the mindset that you're in the base language again, and that if I need you to write a function that does something, I need you to write the function that does something, and I need you to pass the test. Because the test is going to be, 1, forcing you to put the bananas to invoke it, and 2, forcing you to write the return statement, which is important to get used to. Cool? All right. The last thing I want to focus on is W3 Schools is great for HTML and CSS. So you probably used it a lot when you were in mod 2. The Bible for JavaScript will be the MDN, the Mozilla Developer Network. Okay, my internet's busted. You'll want to go to the MDN, the Mozilla Developer Network, for any and all of your JavaScript. You want to learn how to write the for each, you want to learn how it works, you want to see an example of it, MDN. Right? Filter, MDN. Anything. Cool? And then lastly, if you want to get really good, I'm going to upload this code, but Airbnb has like a JavaScript style guide. I highly advise you to check it. I don't have internet right now, but you literally just Google Airbnb JavaScript style guide. It really shows you like what a good code looks like versus bad code. Most of the things will tell you, like, for example, like in your HTML, there's a difference between this and this. Like it becomes bloody unreadable. So like Airbnb style guys will be like, hey, when you write something, you should indent it here. Or like camel case and not snake case your JavaScript. But things like that.
Why Airbnb though?
Airbnb is a pioneer in terms of using like JavaScript, like asynchronous requests, which we're going to talk about and learn in Mod 3. And there wasn't actually an official style guide. So Airbnb just took it upon themselves because a lot of the developers there are very senior JavaScript developers. Like, okay, I've seen a ton of code. Some of it's gross and some of it is good. So let me put out a style guide. And Airbnb actually has a lot of style guides. They have one for Ruby and a bunch of other things, React as well. So they've become sort of like, they've taken it upon themselves to do it. It's widely accepted amongst the developer community. All right, sorry that was kind of long, a little bit dry. The first two usually are. Tomorrow is gonna be super fun. So let me just, this is like a fun meme, tells you about the history of JavaScript, and that's really, are there any questions on like the basics of JavaScript?
One. Could we scroll up to the two students that are being declared in that school?
What?
Search for where the school is and come up. I don't remember the exact example.
You're right there.
Fred and Joe, right? So you have the constant Fred and the constant Joe, but you know where it says school equals
An object?
yeah. So
Yeah.
Are we writing that here or is that a return value? Like students?
Got it. Students is not necessarily return. Remember, return is only important for a function.
Okay.
This is just a plain old JavaScript object, a POJO. Yeah, but remember, it's just space immaterial. So in order for the readability, you can kind of put this on the next line.
Okay. And that's proper syntax, just putting it on the next line.
That is correct. Yeah, this is good to go. Yeah. So this is just demonstrating that you have like nested objects. That this object can be a name that points to a string, or it could be an object with a key that points to an array.
Okay.
Yeah, I mean you can do the exact same thing in Ruby. Awesome, great. So let me kill